So now we're going to take a look at two examples where we're graphing with logarithmic functions. But here's a twist. The twist is we're going to be graphing two logarithmic functions, and each one has a transformation. And don't be alarmed, you guys already had experience with graphing transformations. All right, so for the first one, we're going to be graphing log 2 of x plus 6. Now what I have over here is the graph of the parent function. Now the graph of the parent function would be, we have log 2 of x, all right? So that is the parent function. So I'm going to make an x and y table for that one. And I'm only going to use 3 points, all right? So I have 1, 0, 2, 1, and 4, 2. Now I'm getting these points from the graph that we already did, all right? So I'm only taking these 3 points, 1, 0, 2, 1, and 4, 2. And those are going to be my x and y coordinates for the parent function. So now what we're going to do is we're going to figure out what my new graph look like based on the transformation. All right. So if we take a look, we're given the original parent function, the graph for the parent function, along with the asymptote. All right. So we have log 2 of x plus 6. Now we see that plus 6 is inside the parentheses. That means it's within the x. It's inside the equation. So with that being said, what kind of transformation is that going to be? If you guys said a horizontal asymptote, then you're absolutely right. If you guys don't recall the transformation, so I want you guys to look back into your notes or in the last packet for the reference. All right. So now what we're going to do is we're going to do the horizontal shift. So that means, with the horizontal shift, we're either going to move 6 to the left or 6 to the right. Now with the horizontal shift, remember, we follow the opposite sign. So the opposite of plus 6 would be a minus 6. And with that minus 6, we would read it as 6 units to the left. So that means I'm going to move each point 6 units to the left. But not only the point, but I'm also going to move this vertical asymptote 6 units to the left. All right? So let's go ahead and get started. So I'm going to first move the vertical asymptote 6 units to the left. So we have 1, 2, 3, 4, 5, 6. Okay? So now I'm going to move each point 6 units to the left. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Let me see. 1, 2, 3, 4, 5, 6. Okay, yeah. And over here we have 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. All right. So we have 1, 2, 3, 4. Also, it should be over here. 4, 2. Not 5. 4, 2. So we have 4, 3, 2, 1, 0. So 1, 2, 3, 4, 5. So it would be over here. It would be at -2, -2, not this one. Let me just X that out. All right, so I'm going to go ahead and connect the 3 points. And that's going to be my transformed graph. That's going to be my graph for this function, log 2 of x plus 6. All right? Now remember, with the horizontal shift, it's also going to move the asymptote. So let's take a look at example number 2. So we have example 2, where we have 4 times log 2 of x minus 1. And I already have my graph for the parent function. I'm going to go ahead and make an x and y table for that one. So I have x, y, 1, 0, 2, 1, and 4, 2. All right? Now what we're going to do is we're going to figure out what is the transformation happening between this 4 in the front and the minus 1 on the outside. Okay, so there's 2 transformations going on. So since there's not just one transformation like the previous one, I think it's best if we make another x and y table just so that we don't get lost. we don't get lost with trying to do two transformations. Is that 4? Now with that 4 is in the front. Now with that being said, that's going to be a vertical stretch. So it's going to stretch each point by 4. So if it's stretching vertically, that means it's going to change the y value. So we have 4 times y. All right? So we have 4 times y. And then after we have the vertical stretch, we have the -1, which is outside of the equation. It's not like it's inside for as like number 1. All right? So with that, that's going to be my vertical shift. And the vertical shift, we follow the same sign. So that means I'm going to go 1 unit down. So after I stretch each y value by 4, I'm going to subtract each y value by 1 since we're going down. So the x values stay the same, but the y values change. So I have 1, 2, 4 for the x values. Nothing changes. But now the y values are going to change. So first off, I have 4 times 0, which is 0. And then I subtract by 1, I get -1. Then I have 4 times 1, which is 4. Then subtract that by 1, I get 3. Then I have 2 times 4, which is 8. And then 8 minus 1 is 7. So these are my 3 values. These are my new y values. So I'm going to go ahead and plot those 3 coordinates. So I have 1, down 1, 2, up 3, 1, 2, 3, 4, up 7, 1, 2, 3, 4, 5, 6, 7. All right? So I'm going to connect them. All right? So this would be my new graph. This would be the graph for 4 times log 2 of x minus 1. All right, so the only thing that really changed was the graph. The vertical shift is still there because all we just did was we stretched the graph vertically and we moved each point vertically as well. All right.